Hello everyone, I am Soniya Malik and I will be giving presentation on numerical method for polynomial root finding. So in this presentation, we will be covering topic like theory of polynomial roots. Then we will discuss some numerical method in root finding, and then we will see their MATLAB code and some example to solve the polynomial. And first of all, what is the root of a polynomial? So consider we have a polynomial equation as fx is equal to an x raised to power n plus an minus 1 x raised to power n minus 1 up to so on. So root of a polynomial are the values of x that satisfy the equation fx is equal to 0. To understand better, we can visualize this as follows. Consider we have a quadratic equation as fx is equal to ax square plus bx plus c. So when we plot the fx versus x graph, the values of the fx that cut or intersect the x-axis will be the roots of this polynomial. So we can see here the graph of fx versus x intersect the x-axis at 2 points x1 and x2. So these are the roots of the polynomial fx. So there's fundamental theorem of algebra that says that polynomial of a degree n has at least one zero. So this theorem guarantee the existence of root for all non-constant polynomial. They need not to be real. There are some polynomial that have complex root. If consider we have a polynomial that does not intersect the x-axis, that has complex root. So this fundamental theory of algebra states that every polynomial has at least one root, real or complex. So the complex root always occur in pairs, and this fundamental theory of algebra is very important to understand the polynomial equations, and it has various applications in mathematical fields. So then we have some algorithm to find the root, or say zero. Zeros are the basically same as root of a polynomial. So sometimes it is impossible to find the exact solution. So then we go for the approximate solution of the polynomial. And these algorithms give close approximation to the values of roots, and sometimes give interval or say floating point. In case of complex roots, we get an interval in which the root lies. So it gives approximate interval in which the root of a polynomial lies. So now consider we have an equation fx is equal to gx. So to solve this equation, we will have hx is equal to fx minus gx and then find the roots of the hx, and we can solve this equation. So one more thing is that these algorithm does not assure finding all the roots of the polynomial. So sometimes there are some roots that get undetected. This basically depend on the initial value we choose. So it does not guarantee to find all the roots of the polynomial. So why we choose numerical techniques? Why we choose these numerical methods? So first is the complexity. So sometimes the polynomial is so complex to solve analytic. So we go with the numerical techniques to find the solution. And next is when we encounter the real value problems. So we encounter some polynomial that are difficult to solve analytically. So we use numerical technique in real world problems. And next is numerical techniques are more efficient than analytic methods. So next is sometimes we do not even require the exact solution. We just need approximate solution for a root of a polynomial. So in this case, numerical techniques are far better than analytic method. So next is if we have complex root of a polynomial, then sometimes it gets difficult to solve it analytically, and we go for the numerical technique to solve polynomial having complex root. So we have several methods like bisection method, false position method, ITP method, and some interpolation method like Newton-Raphson method, secant method, fixed point iteration method. So in this presentation, we will be covering bisection method and secant method in particular. So first, we will discuss the bisection method. So bisection method is a numerical technique to find approximate solution of a real valued function root. So how this bisection method works? So basically, we have to choose an interval, say a to b. Then we have to calculate the value of the function at these 2 points, a and b. If such that these f a and f b have opposite sign, this guarantee the uh, root in this interval. So if f a and f b have opposite sign, so this means that there is a root in the interval. So then we calculate a c, as the name suggests, it will bisect the interval a and b. So we will have c is equal to a plus b by 2. Then we will calculate the value of the function at this point. If it is equal to 0, then this is the root. And if it is not equal to 0, then we will check for the signs. If fc and fa has same sign, then the root will lie in the interval c to b. Otherwise, it will lie in the interval a to c. So again, if uh, fa and fc has same sign, then we will replace a with c and do the same procedure until we get an approximate root within the desired tolerance. And this is how bisection method works. So now we will see its MATLAB code. So first, this is the code to define the function to calculate the root of the bisection method. So here are the variables A, B, F, tolerance, maximum iteration. So first we calculate the value of the function at a and b. So FL is the inbuilt function that will calculate the value of the function f at the position a. So we will calculate f and fb. If both has same sign, then it will show an error that function has same sign. And within the limit b minus a by 2 is uh, greater than tolerance, then we will start a loop from 1 to maximum iteration. Then we will calculate the value c as the midpoint of a and b. Then we will calculate the value of the function at c point. If it is equal to 0, we will declare the root as c. If it is not so, then we will check for the sign. If fc and fa has opposite sign, then uh, we will uh, so if fc and fa has opposite sign, we will change b with c and fb with fc. And if they have same sign, then we will change a with c and fa with fc and do the procedure until we reach the maximum iteration, and root will be the new a and the b by 2. So next is this is the main code. So we define the function, uh, and then we have the values of a and b, the endpoints. Then we have the tolerance value. Then we have the maximum iteration, and after declaring all these, we will call the function that we have created to calculate the root of the polynomial. So here the output of the bisection method for x square minus 5 as function. So next we have the secant method. So secant method is also a method to calculate the root of a polynomial. So in this method, we will have to guess two value x0 and x1 in which we want to find the root of the polynomial. So the formula for the secant method is equal to x2 is equal to x1 minus fx1, x1 minus x0 by fx1 minus fx0. X1 and x0 are basically the two initial value we have chosen, and fx1 and fx0 are the value of the function at x0 and x1. So next we have the function for secant method. So we have the variable as f, x0, x1, tolerance, and maximum iteration. So first we choose iteration is equal to 0. If iteration is less than maximum iteration, we will have this formula as we discussed. X mu is equal to x1 minus fx1 into x1 minus x0 by fx1 minus fx0. So if the difference between x mu and x1 is less than tolerance, then the root will be x mu. Else we will change the x0 with x1 and x1 with x mu and increase the iteration by 1, and the loop continues until we reach the maximum iteration. And so here's the main code. So we define the function, then we will give the values x0 and x1, then we give the tolerance and maximum iteration and call the secant method function that we have created to calculate the root of the polynomial. So here's the output for the secant method. So in this presentation, we discuss the theory of the polynomial root, and we discuss some numerical techniques to calculate the root of a polynomial and showed example using MATLAB code. So if you have any doubt, you can contact me. So thank you for your patience to